If you've ever had a hard time doing those problems that give you some function f and some function g and tell you to describe the transformations to go from f to g, this is exactly the video you're going to want to watch, because I'm going to show you an example of how to do a problem like this in reference to another video I made recently about a blueprint that you can apply to all sorts of these different kinds of problems. And so by the end of this video, this process should be much easier for you and you should be feeling a lot better about it. So if that sounds good to you, be sure to stick around to the end of the video. I will link to that other blueprint video I mentioned at the end of this one, so you can go check that out next if you want. But stick around, watch this example, should help you feel a lot better about these problems. So let's go ahead and jump right into it and I'll show you what I'm talking about. Describe the sequence of transformations from f to g, where f is the parent function. So that's going to be the first thing we need to do, is think about what is our parent function. And then the function g that we are given here is negative, in parentheses, x plus 10 squared plus 5. So again, we want to basically start with our generic transformation template, which is our function g of x is going to be given by a times f of b times x minus h plus k. So then what we can do is figure out what is our parent function. Well, our parent function, again, is just going to be the most kind of simplified version of whatever the function we are given it is, without any sort of transformations applied to it. So in this case, again, since we have really x being raised up to the second power, that tells us that our kind of most simplified version of this function is just going to be x squared. So obviously we have, this minus sign being multiplied out here. We have x plus 10 in here. We have a plus 5 out here. All those other things are kind of just noise that you can ignore. The really kind of most simplified basic version of this function would be x squared. So that's going to be our parent function. Again, that's a very common parent function that you're going to be dealing with. Now what we want to do is apply the parent function we figured out to this g of x and figure out kind of a new template, which is specified for transformations specifically having to do with the parent function x squared. So to do that, all you have to do, all this notation means, again, is if we have this f of something, f of all this stuff here, all that tells us is we're going to go to our function f, and wherever we see an x, we're going to replace that x with whatever is inside the parentheses, f of all this stuff. So this stuff is just going to be plugged into our function f for x, which means we're just going to go to our function x in our function and replace it with all this stuff. So we're going to have basically just whatever is inside here, b times x minus h, all raised up to the second power. So b times x minus h, all raised up to the second power. And that is just f of b times x minus h. Then you still have a times that, and then you have a plus k at the end. So now this is our transformation template, which is specifically tailored to the parent function that we figured out, which is x squared. So now what we need to do is interpret this, compare it back to the original function we were given, and figure out what the different transformations are that are being applied in this case. Okay. Before we get into that, if you are getting some value out of this video so far, do me a favor, hit that like button down below. It's a huge help to my channel, so I can keep making more videos like this. Hit that subscribe button and that bell icon while you're down there too. So, if you're getting some value out of this video, I'm going to have plenty more videos that you're going to get value out of. We'll keep crushing it all term long and pre-calc together, or calculus, whatever math class you're taking. All right, but let's carry on with finishing up this problem. So now we really just want to compare basically where are the pieces that we were given some stuff that kind of corresponds with our template. So you can see we have this minus sign out here. That basically corresponds perfectly with our a value here. So that's going to tell us that it's going to have something to do with our vertical stretching, or when you have a negative, it's going to generally have to do with kind of reflecting across the x-axis. We don't have a b value here because there's no number being multiplied by our x, so we don't have to worry about any horizontal stretching or compressing. We do have some value here impacting our horizontal shift, since we have x plus or minus some number inside the squared here. So we are going to have, be dealing with some sort of horizontal shift. And then we do have a number being added out here at the end. So we are going to be dealing with some sort of vertical shift, moving it vertically up or down. So what are these numbers? What do they tell us about our function? So our a in this case is basically just -1. It's a negative, but there's no actual number kind of changing it to stretch. So what that tells us is we're going to be reflecting vertically across the x-axis. So reflect across the x-axis because it's -1. If it were some other negative number, it would also stretch or squish it in the vertical direction. Since it's -1, it's not going to be stretching or squishing it. It's just going to reflect it across the x-axis. Okay. Then we also have this +10, which is in the spot of our -h, which tells us that we're going to be shifting. So we're going to shift 10 units to the right. I'm sorry, 10 units to the left. Because since we had x plus 10, that tells us we're going to move 10 units in the negative direction, 10 units to the left. So that's something, again, you want to be very careful about. If you have x plus some number, you're going to move that many units to the left. If you have x minus some number, you're going to move that many units to the right. So it's going to be a little deceiving. It's always going to behave in the exact opposite way that you would expect it to just by looking at it. Plus means you move in the negative direction, minus means you move in the positive direction. Okay. Then finally, we do have this +5 out here. With k, with our vertical shifting, that's going to behave the way you would expect it to. So +5 means we're going to move 5 units up in the positive y direction, 5 units up. So these are basically the 3 different transformations that are being applied from our parent function f to get to this function g that we were given here. Reflect across the x-axis, we're going to move it 10 units left, and then we're going to move it 5 units up. Well, as promised, I linked to that video right there. You're definitely going to want to check that out. It just talks about the general blueprint that you can apply to any of these problems, similar to the one that we just talked about, to do them all much, much easier. This one example is great, but you're definitely going to want to see that blueprint because it's going to work for all the rest.